Loudspeakers take an electrical signal and turn it into sound. A magnetic coil and a permanent magnet attract and repel each other. As the coil moves back and forth, it causes a flexible cone to vibrate, which in turn vibrates the air in front of the speaker, creating sound waves. Loudspeakers contain at least two magnet and cone assemblies, known as drivers. They're typically housed in a box called a speaker enclosure. To build the internal magnetic structure, the factory begins by cutting two plates of iron, each about 13 millimeters thick. They go one at a time onto a lathe. First, the machining tool smooths and evens out the surfaces, getting rid of any marks made by the saw. Then it cuts a small hole in the center of one plate and a larger hole in the center of another. Next, they cut a smaller and thicker round piece of iron called the core. A reamer bores a large hole through it. They apply super high-strength epoxy glue to the core and to the back plate, the plate with a smaller hole. They glue and screw the pieces together because the bond has to be strong enough to withstand intense magnetic pull. They glue a foam filter in the hole to ensure the vibrating cone doesn't draw in dust and cause internal damage. Now they spread glue on the narrow end of what's called the metal basket, a die-cast aluminium frame that will hold the magnetic structure and cone. They screw the front plate, the plate with the bigger hole, onto the glued surface. Then they glue the underside of the front plate and one side of a ceramic ring made from iron powder, known as ferrite. After adhering the ferrite to the front plate, they apply glue to the other side of the ferrite, then flip the basket over to attach the back plate. The core fits through the large hole in the front plate. They insert shims to center it while the glue dries. After screwing terminals to the basket, they put the entire structure they've just assembled into a magnetizing machine with 600 volts of direct current. The machine creates positive and negative poles, transforming the magnetic structure into a permanent magnet, meaning it has a constant magnetic field around it. Now they wind the voice coil, the electromagnet that will interact with the permanent magnet. An electromagnet only generates a magnetic field when there's a current running through it. They wind enamel-insulated copper wire, gluing it to a rigid plastic sheet. The positive pole of this voice coil will be attracted to the negative pole of the permanent magnet. And, you should remember this from school, negative poles will repel each other. The voice coil's poles are constantly reversing position because the electrical current running to the speaker is an alternating current, meaning it switches between a positive and negative charge several times per second. This makes the magnets attract and repel each other continuously, causing the voice coil to move back and forth rapidly. This vibrates the cone, which creates sound waves. Simple. After slipping the voice coil between the front plate and the core, they glue on the bottom suspension, flexible fabric rings that move with the voice coil and prevent it from rubbing on the magnetic structure. Next, they glue the cone. It's usually made of cardboard, plastic or metal. Then they solder the electrical connections. The current coming from the amplifier travels by wire to the two terminals. The terminal wires connect to the voice coil wires. After making sure the cones move freely without rubbing, they glue on a rigid cardboard cap to keep out dust. The last step is to take the speaker for an audio test drive. They connect it to a machine that transmits different frequencies. They make sure the movement of the voice coil and cone isn't obstructed in any way. Then a computer analyzes the sound wave the driver sends out. Two-way speaker systems have two drivers in each enclosure, a woofer and a tweeter. A woofer has a large cone that vibrates more slowly for low frequencies. Tweeter has a small cone that vibrates quickly for high frequencies. Three-way systems have a third driver with a medium-sized cone for the mid-ranges. So, all you need now are some mates to dance with. When you're staying at a hotel, fumbling with your door keys has become a thing of the past. The key card bears no room number, so in a tired or weakened state, you can afford to leave it in the restaurant. If you've managed not to lose it, you swipe or insert it to unlock the handle and get in. Clever stuff. The metal case that contains the door lock's mechanical and electronic components is called the housing. To make the housing, they begin by melting zinc ingots at temperatures of around 390 degrees Celsius. Die casting machinery then injects the molten zinc into molds. Between injections, sprayers coat the empty mold cavities with a release agent, the industrial equivalent of greasing a baking pan. A built-in cooling system hardens the metal. Then a trimming die cuts off any excess zinc. Meanwhile, the electronic circuit board, the brain of the lock, takes shape. Aptly known as the pick and place machine, this machine picks up the 60 or so electronic components and places them in the right position on each board. This computer-guided machine installs 15,000 components every hour. Next, the boards undergo wave soldering. A mix of molten lead and tin surges up from underneath, fusing the components in place and creating electrical bonds. Then both sides of each circuit board get a coat of silicon-based sealant. This protects the components against the elements. Meanwhile, back at the housing, workers lubricate them with grease. Then apply what's called a sleeve bearing, a nylon bearing jacket that enables the handle to turn smoothly. Next comes the drive tube, onto which the lever will be assembled on the other side. There are several clutch components that link the lever to the latch. Swipe the right card, and they permit the latch to retract. After applying more lubricant, they install an override that enables the hotel to open the door with a key if for some reason the electronics malfunction. They fit the circuit board and connect it to the various parts it controls, such as the clutch motor. Now they close up the completed housing with a steel backplate. This protects the components inside from rusting. The last step is to insert a battery pack. It holds 3 standard AA batteries. The factory tests the lock using a test key card, because the lock isn't yet programmed to work with a specific card. That's done after installation. Elsewhere in the factory, they assemble the mortise, the part of the lock that goes inside the door. When you lock a door, the mortise's bolt comes out of the door's edge and fits into the hole of a receiving piece called a strike plate in the door frame. They close up the mortise with a back plate. This demonstration shows how they install the mortise in the door. Once it's in, they screw a decorative plate on top. And here's the handsome finished door, complete with electronic lock. Keycards have instructions on one side, a magnetic data strip on the other. They use a generic card to test every lock that comes off the production line. In the quality control lab, they subject each new design to several rigorous tests. They open and close 1 million times. They subject the lever, latch and lock to repeated impacts. They are brutal and abusive. They also test lock function in extreme temperatures. These electronic door locks come in several metal finishes plated over the zinc, and even in a painted finish that simulates wood.